We are now going to get rid of the async and await keywords again, simply because I want to explore an alternative approach of introducing a continuation and obtaining a result. We have two expensive operations in this code block. The first one reads all the lines from the file, which obviously takes a little bit of time, especially if the file turns out to be really large. Then there's the process of parsing and processing each line, and this operation may take a little bit of time as well. This is why we'd like to avoid running these two operations on the UI thread. We can refactor the code a little bit to split these two operations into multiple steps. The first task will load all the lines asynchronously from the file system, and the task will then return its content. Whoever then subscribes to when this task completes will be able to grab the result inside the continuation. This task represents an asynchronous operation that, when it's done, will return an array of strings. We could optionally use the generic version of task.run to explicitly say that we are expecting this to be a task of array of string. However, that's inferred by the compiler, so we don't have to explicitly say that here. At this point, we could use the async and await keywords, but as mentioned earlier, we want to do this without using async and await. Instead, you can chain on a continuation onto a task with a method called continueWith. This creates a continuation that executes asynchronously when the target task is completed. This means that the continuation is also executed on a different thread. Just as we did with task.run, we can represent the operation that we want to run using an anonymous method. The method executed by continueWith accepts a parameter. This will take the task that just completed. So inside the continuation, you can access the task that was just completed and executes this continuation. Do you remember the result property that I told you to never use? You're going to use that now. If you recall, I did mention that you can use the result property if the value is available. If it's not available and you call result, it will block until that operation completes. But when we're inside the continuation, the task will have ran to completion and there will be a result available. Therefore, it doesn't lock any threads. The result property contains what the task returns. In our case, this will be an array of strings. We'll iterate this array of strings and produce a stock price instance for each element. The continuation is now chained onto the task and will run as soon as it completes. What's interesting with continueWith is that it in fact returns a task as well. It could therefore return a result, but at the same time, it could also throw an exception that we'd have to make sure that we capture somewhere in the application. It also means that you could chain on another continuation to the task that is returned by continueWith, which also returns a task, and you could chain on another one to that one. Then you could chain on another one, and so forth. You could add as many continuations as you'd like. Each one would execute the task that it's chained on once that task completes. A task can even have multiple continuations that will all execute once the task completes. Since continueWith is an asynchronous operation, it also means it will run on a separate thread. So to invoke the UI, in our case, we have to use the dispatcher. We'd like to avoid the same bug we saw earlier, where it said that the operations completed super fast, but at the same time avoid introducing the async and await keywords. You can do so by chaining on a final continuation. In this case, I can simply use a discard to say that I don't care about the parameter. That will run the last portion of the method on the UI thread. What we've achieved now is that we've introduced an asynchronous operation that will load the file content from disk. When completed, the array of strings will be returned. We attach a continuation that will convert each of these lines into the stock price instances and then populate the UI. In a final continuation, we then remove the loading indicator from the application. The application is now as good as the one that we had at the end of the previous module, but without using any of the async and await keywords. While this is an alternative approach to subscribing to an asynchronous operation, and when it's completing, it also shows how much you get out of the box when using async and await. If we compare this to the async and await approach, this here is a little bit more noisy. There's a lot more code. I would say that it's more error-prone, and it doesn't really read as nice as the async and await version did. There is also a difference in that the continuation in this case is executed on a different thread, which, as we saw, could be a little bit problematic. When we wanted to interact with the UI from the continuation, we had to introduce the dispatcher for every time we want to invoke anything on the UI. Sometimes introducing the async and await keywords is a little bit unnecessary. As you will learn later in this course, it does introduce a lot of generated code. In those situations, an alternative approach where you can only use things in the task parallel library might therefore be needed. If we try to load a file that doesn't exist, nothing happens in the application, except the final continuation did in fact remove the loading indicator and updated how long it took to execute all of the code. You notice here that it did try to load the stocks. That task failed. Then it's executing its continuation. This is really a big difference from how the async and await approach worked. This just shows you that there's still a long way to go to make this as good as our async and await version was.